Hello girls, to continue with the atomic structure, chemical bonding in chemistry. Today we are going to learn about the atomic structure, that is the structure of an atom. Now, I already told you in the previous upload that an atom is made up of subatomic particles, smaller particles. There are three: positive particles, which are known as protons, negative particles, which are known as electrons, and particles which do not have any charge are known as neutrons. So how does it look like, or how is it arranged? You will see that at the center, just like the solar system, the sun is there in the center and the planets are revolving around it. So in the place of the sun, there is the nucleus. Now, what is the nucleus made up of? It is made up of positive particles. Okay, these are the positive particles, very tiny particles which we do not see with our naked eyes. Okay, and neutral particles. This white one which I am drawing here are the neutral particles which do not have any charge. They are all concentrated at the center, and this is known as the nucleus. So what do we have in the nucleus? Positive protons and neutrons which do not have any charge. Okay, and then just like the planets revolve around the sun, the electrons, okay, there are orbits, imaginary path. If you remember the energy levels K, L, M, N, or energy level 1, 2, 3, 4, and so on, okay, you will see them around the nucleus. So what do we find in the nucleus? We find negatively charged electrons. Okay, negatively charged electrons. The first orbit will have 2 electrons. The first orbit cannot have more than 2 electrons. It can have less than 1 electron, less than 2 electrons, but it cannot have more than 2 electrons. So if there are some extra electrons, supposing here in this I have drawn 3, the extra will move on to the next energy level. So if it is 4, it will come here. If it is 5, it will come here. If it is 6, it will come here. The second orbit cannot hold more than 8 electrons. Maximum electrons it can hold how many? 8 electrons. Okay, so beyond that, if the second orbit has more than 8 electrons, the next one, the ninth one, will jump to the next level. Okay, so here you can see this is the basic structure of the atom. Okay, the nucleus has positive protons and negative, which does not have any charge, that is neutrons, and the orbit, in the orbit revolving around, in the orbit like the planets, you have the negatively charged electrons. Okay, so there are different levels of first orbit, second orbit, third orbit, or orbit K, L, M, N, and so on. Okay, now what are orbits? They are imaginary paths where the electrons revolve around the nucleus of the atom. Okay, now when we talk about atomic number, okay, it is written as capital letter Z. Okay, so an atom of an element, they have their own number of protons in their nucleus, which distinguishes it from the atoms of other elements. So each element will have a particular number of protons. It is different for different elements. Okay, so this number of protons is known as the atomic number, which is written as Z. Okay, the atomic number is equal to the number of electrons, the positive, that is the protons, which is the atomic number, is equal to the negative, which are the electrons that are revolving in the orbit. Okay, so that is why always an atom is electrically neutral. It does not have any charge. Supposing an atom has 10 protons and 10 electrons. You know, number of protons is equal to number of electrons. So what happens is 10 positive charge and 10 negative charge, they will cancel out, and what will the net result be? It will be equal to 0. That is why an atom is always electrically neutral. It does not have any charge. Why? Because the number of protons is equal to number of electrons. Now next we are going to talk about mass number, which is written as a capital A. Okay, now what is mass number? Mass number is nothing but it is the total number of protons and neutrons that you find in the nucleus of an atom. So this is equal to the mass number, which is written as A. Okay, now remember children, this mass number is actually a whole number which is approximated. All the atomic masses are calculated of the protons and the neutrons, and an approximate whole number is given, and it is calculated in AMU. You know AMU means atomic mass unit. Okay, now next we will talk about the distribution of electrons in the orbit. So distribution of electrons, I already told you when I was explaining the atomic structure. The first orbit will have 2 electrons. It cannot have more than 2 electrons. Similarly, the second will have 8 electrons, and so on. So here I am going to talk about in detail. So distribution of electrons in different shells is known as electronic configuration. Okay, so distribution of electrons in different shells was suggested by Bohr and Berry. These are the name of the chemists who learned, who studied about the atom. Now the rules are there for writing the number of electrons in different energy levels or shells. Now, as I already told you, the maximum number of electrons in the first orbit is 2, second is 3. So a formula is followed. Okay, so the formula is 2n square, where n is the serial number of the shell. The first shell or K shell has 2 into, this is n square, so 2 electrons. Second will have 2 into 2 square, 8 electrons. Third will have 18 electrons. Fourth will have 32 electrons, and so on. So this is the formula you must remember when you are asked about the maximum possible number of electrons in different energy levels. Now, electrons are not accommodated in a given shell unless the inner shells are filled. That means the first shell must have 2 electrons. Okay, this is the second must have how many electrons? 8. Okay, so the third after 8, if there are total, supposing 8, 9, 10, supposing 12 electrons are there, how will you divide it? First shell will have 2, second will have 8, so 8, 9, 10, how many are remaining now? 2. So that will move on to the third shell. So this is the arrangement of electrons in the atom, and this is known as electronic configuration. Okay, now the outermost shell of an atom cannot accommodate more than 8 electrons, even if it has the capacity to accommodate more electrons. For example, if we take a look in calcium, which has 20 electrons, 2, 8, 8, 2. Outermost cannot accommodate more than 8. So it will move to the next orbit. Clear? Now, the maximum capacity of M shells is 18. Okay, you know that when we're talking about the third shell, when we use the formula 2n square, it has to be 18. But only 8 electrons are filled in it, because the elements become stable only after it has 8 electrons in the outermost shell. That is known as octet configuration. Now, the outermost shell of a chemically stable atom can accommodate a maximum of 8 electrons. Okay, so that is known as octet, I already told you, except helium atom, which has only one shell and it can accommodate only 2 electrons. So this is known as duplet configuration. One shell and only 2 electrons. Okay, so now I'm going to teach you how to draw an atomic structure. Supposing we take an element X, okay, the mass number will be written as a superscript in front of the formula of the element, and the atomic number is written as the subscript in front. Okay, so supposing, for example, let me take silicon. 28 is the mass number. Mass number means the number of protons plus neutrons in the nucleus, and then 14 is written, and you know what is 14? It is the atomic number. So when we talk about atomic number, we are talking about the number of protons, which is equal to number of electrons. We need to know the number of electrons in order to draw the atomic structure. So first we need to write down number of protons, and you know you can easily take out the number of protons from the atomic number because it is equal to 14. Then you will find out number of electrons, that is equal to 14 only. Why? Because the number of protons is equal to number of electrons. Now supposing you are asked to find out the number of neutrons, what will you do? You will subtract 28 minus 14. 28 is the number of protons and neutrons, and this is number of protons, so you will subtract is equal to 14. Now from here, before you draw the electronic structure of the atom, what you do is you have to write down the electronic configuration. Okay, so you know I already told you, electronic configuration is the arrangement of electrons in each orbit. So there are 14. So you'll first one, as I already told you, will have 2. Then next will have 8. So total 8 plus 2, 10. So out of 14, how many remains now? 4 remains. So this is your electronic configuration. Okay. Now the outermost orbit tells you the valency of that element. Since we are talking about silicon here, what is the valency of silicon? It is 4. So to draw the diagram, you will draw the nucleus in the center like this. 2 electrons. Then there are 3 orbits. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and the third will have 4. 1, 2, 3, 4. Instead of this, what you can also do is just make dots. Okay, you can use colorful dots or to show the 2 electrons in the first one. Okay, then second and third. Second has 1, 2. See, if you draw this way, it will be easier. 4 directions and then in the middle. 7, 8. Okay, now 4. 1 at the top, 1 below. It look balanced and it look neater also. So this is the atomic structure or the orbital diagram of silicon. So for your assignment, children, go to page number 61 and draw the diagrams of the first 21 elements that is given there. You do it in your copies and submit it day after tomorrow. Till then, children, stay safe. God bless you.